Hello everyone, Eric Severy here, and welcome to my computational science video tutorial. Today we're going to be looking at mathematical functions with Python. And we're going to do more than just addition and subtraction. We're going to use some real mathematical functions. And to do that, we're going to have to import some functions from a Python module called numpy. And numpy is short for numerical Python. Now, in Python, there's a lot of libraries out there, and you may have to go find them and download them. For numpy, this is not included with the standard Python, so you're going to have to figure out how to install these. My advice to you is to Google, how do I install numpy on my computer, and it should be very simple and basic to do. I use a Macintosh, and I know very well how to install it on a Macintosh, but that might not help you if you're using a Windows computer, which I know 99% of the people, at least in the country where I live, are using Windows. So figure out how to do this. If you cannot figure it out, leave something in the comments. Let me know, and I'll try do my best to help. But like I said, I'm not a Windows expert. I spend my time doing math and computation. All right, so let's get started. Let's assume we have numpy installed, and we're going to get going. To use numpy, we start with a statement called import, and we're going to import numpy. Like I said, that's short for numeric Python. And once we've imported numpy, we can now do some cool things. We can say that we can compute the sine of x. We can say that we want to write the sine of x, so we want to figure out what is the sine of, here I created x as 0.12345. But to use the sine function, we can't just write sine. We need to tell our Python language interpreter where is sine. Well, sine is inside of numpy. So before sine, I'm going to have to write the word numpy. And then to tell it that sine is part of numpy, we're going to put a dot. And here the period is indicating that you look at numpy, and there's something inside of numpy called sine that we're going to be able to access. And numpy is really a collection of mathematical functions, constants, and things like that. So we can do numpy sine of x. We could do numpy dot sine. And in fact, we can use numpy for the input. We can say numpy.pi. Now, numpy.pi is not a function. It's actually a variable, or more accurately, a constant of pi, which is 3.14. So we can print these to the screen by just putting these in a print statement. So we'll just slip a print and some parentheses around these. Now, I've already run this program, so I don't need to go to click run, but I can do it anyways. All right, so the sine of our 0.12345 gives us 0.12313 blah blah blah. And the numpy of sine of pi, well, we might have expected 0, and we don't get 0. However, when we look at this in exponential notation, we see, oh, it's 1.22 times 10 to the negative 16th. All right, so this isn't 0, but it's really close to 0. So we're going to call this 0. So this is how we use our numpy functions, is this numpy dot something. Now, if we don't want to write the whole name numpy out, if we're feeling lazy, we can actually shorten it. So we can import numpy as mp. And this can be a very convenient thing, which we'll see in later tutorials. We can take a really long name and make it really short. Now, when I change this to numpy, my PyCharm interpreter says, hey, there's no numpy. That's because it's looking for np. So we just have to change all these numpys to np. And the shortening of np is a very common way to shorten up the name for numpy. A lot of scientists use np as a quick shorthand for numpy. So if you're looking at scientific code and they say np.sine, they're talking about the numpy sine function. All right, if we wanted to use a function like cosine, there's a special, well, this will work for any function, but there's another way we can import functions where if we know we only want the sine and cosine from numpy, what we can do is we can say, well, from numpy, let's import cosine. And this is going to look in the numpy package, and it's only going to import cosine or sine. And we can actually simplify our print statements a little bit more, and we can say print, sine of x, or print cosine of x. Oops, not x0. Now, I'm not a huge fan of this second way of importing, although I know it's very common. And the reason I'm not a huge fan is I do like a little bit of a reminder that we're using the sign function that's defined by numpy. Different packages might have similar named functions, and by giving our function, by giving our package names a little short name, it allows us a quick and easy way. Now it is 3 more characters of typing, but it's really not too bad. But I do want you to know that both options are available. If we run our program now, we're going to see we get the same values. Oh wait, no, not exactly the same values, but we get similar values both times. Well, the cosine one should be, if I really wanted the same values, I'd be print sine mp.pi. Now, we have to be careful. If I try to just put print sine of pi, we're going to get an error because pi is not defined. And the reason pi is not defined is we only imported cosine and sine by name. And for all other numpy things, we have to use np. So for pi, we do need to still have np.pi. We can also do other variables like np.e. So we can do the sine of np.e. Well, it's 4.1. So this is just kind of a quick and easy look. If you want to explore what kind of functions are in numpy, you can go to the documents page for Python, or you can just type np dot, and your editor will think for a minute, and it'll give you a list of the different functions. I usually ignore the ones that start with an underscore. Scroll down a little bit until we start finding stuff. Okay, so you can see here we have the arc cosine, or the inverse cosine. If we have arrays, there's an append way. So if we have a numpy array, it'll append things. We have all the arc functions. We can create numpy arrays. And just, I think as you're working with math more and more, you're going to start to use more of these functions. So in general, I think setting up, you're going to have to get numpy installed, and you're going to have to start working with it. And as you get more comfortable doing things in numpy, you're going to be able to do more with it. For now, we're not too far into the logic of our coding in this series, so I don't want to go too deep. But I do want you to know how we can import packages. Another package we'll be using a lot, at least for the course I'm teaching, is the turtle package, which will be import turtle. We're not going to use it in this video, but importing is a way that allows us to get to more complex packages, and the numpy package gives us very quick access to some mathematical functions. Alright, that's everything today. Thank you for your time. I hope you enjoyed the video, and keep on coding.